Dear students, welcome to the fourth session of our chapter 6 Thermodynamics. Today we will deal with the topic lattice enthalpy. How we can define the enthalpy? It's the energy, heat energy. So what do you mean by lattice enthalpy? It is of an ionic compound is the enthalpy change which occurs when one mole of an ionic compound dissociates into its ions in the gaseous state. That is said to be the lattice enthalpy of that ionic compound. Like NaCl, if you are taking NaCl, Na plus Cl minus ions are having. So when this NaCl dissociates, we get what? Na plus Cl minus, and it's having a lattice enthalpy which is given as 788 kilojoules per mole. Since it is impossible to determine the lattice enthalpies directly by the experiment, we use an indirect method where we construct an enthalpy diagram which is named as Born-Haber cycle. So the same reaction, it is constructed in different steps, is said to be what? Born-Haber cycle. Let's see the cycle. Here this is a Born-Haber cycle for NaCl molecule, and it dissociates into Na plus and Cl minus ions. There are 5 steps. The first step is the sodium is which is in the solid state, it changes to gaseous form. That is said to be what? Sublimation of sodium metal, and there the enthalpy of sublimation is there. Standard enthalpy of sublimation is given as 108.4 kilojoules per mole. The next step is this sodium gaseous form is converted into what? Na plus in the gaseous state plus 1 electron. Loss of 1 electron is there. So that is said to be what? The ionization of sodium atoms, which is named as what? Ionization enthalpy. Ionization enthalpy is given as 496 kilojoules per mole. The third step is the dissociation of chlorine, that is Cl2. Half Cl2 gaseous form changes to Cl in the gaseous form. So that is what? The reaction enthalpy is half the bond dissociation enthalpy. So it changes to 1 by 2 bond enthalpy, bond dissociation enthalpy, which is given by 121 kilojoules per mole. Fourth step is the dissociated ion, the chlorine, accepts 1 electron to give what? To get what? Cl minus in the gaseous form. Electron gained by chlorine atoms. The electron gain enthalpy is given as minus 348.6 kilojoules per mole. And the last step is the sodium ion and the chlorine ions in the gaseous forms, they combine to give you what? Sodium chloride. This full cycle is said to be Born-Haber cycle. And here we are getting the different enthalpies which together gives you what? 788 kilojoules per mole for the dissociation of NaCl. Next we have to see the property entropy, and it is defined by the capital S. How we can define in sentences? It is the measure of degree of randomness or the disorder of a system. And entropy is minimum in the case of solid state while it is maximum in the case of gaseous state. The change in entropy is a spontaneous process, and it is expressed as delta S. Delta S means change in entropy. So the delta represents the change. Mathematically, if we want to represent change in entropy, we can write what? Delta S is equal to S final state minus S initial state. That is, the reactant side is also there and the product side also is there. So what we have to do is entropy of the product minus entropy of the reactant. When we do, we'll get the change in entropy. And for reversible and isothermal process, the change in entropy is given as delta S is equal to Q by T. Q is the heat change. So heat energy, Q by T, where it can be written as what? Delta H by T also. And when the system is in equilibrium, we can write delta S is equal to 0. According to the second law of thermodynamics, the entropy of universe is continuously increasing due to the spontaneous process taking place in it. That is, we can write delta S system plus delta S surrounding is greater than 0, or we can say delta S total is greater than 0. So this is the second law of thermodynamics. The third law of thermodynamics is the entropy of any pure crystalline substance approaches 0 as the temperature approaches absolute 0. So the third law says the entropy of any pure crystalline substance approaches 0 as the temperature approaches absolute 0. So we are having here zeroth law, first law, second law, and third law of thermodynamics. Next, we have to see the Gibbs energy and the spontaneity. What is the relation between Gibbs energy and the spontaneity? A new thermodynamic function, the Gibbs energy or Gibbs function, which we say it as G, can be defined as G is equal to H minus Ts. G is the Gibbs energy, H enthalpy, T temperature, S entropy. So if we want to write the change in Gibbs free energy, we can write delta G is equal to delta H minus T delta S. That is, Gibbs free energy is equal to enthalpy change minus temperature into entropy change. Temperature is not having any change, it's a constant there. So delta G gives a criteria for spontaneity at constant pressure and temperature. That is, if delta G is negative or less than 0, the process is spontaneous. So remember, the delta G value, if it is negative, the process is spontaneous. And if it is positive or greater than 0, the process is said to be non-spontaneous. Now let's see the free energy change in a reversible reaction. The criterion for equilibrium is if we are writing a general equation A plus B giving C plus D, we can write there the delta G value as what? 0 for the equilibrium. We know that delta G, if it is coming negative, it is a spontaneous reaction. If delta G is positive, it is a non-spontaneous reaction. So when it comes to 0, it is in equilibrium. When all the reactants and the products are in standard state, we can represent the delta G value as what? Delta G0. That is standard Gibbs free energy change. And it is related to the equilibrium constant of the reaction. So we can get the equation as 0 is equal to delta G0 minus RT ln K. Just rearranging the equation, we can get what? Delta G0 is equal to minus RT ln K. To remove the ln, we can use what? 2.303, which should be multiplied with the term. So we will get what? Delta G0 is equal to minus 2.303 RT log K. As we have learned that Gibbs free energy change is equal to what? Delta H0 minus T delta S0. Right? These are in the standard condition. So we are having here two delta G0 values. One is minus RT ln K, or this one. Removing the ln to log, we will get this equation, as well as delta H0 minus T delta S0 S0, which is written as what? Minus RT ln K also. So this is the relationship with delta G0 and the equilibrium constant. With this, we are winding up the chapter. Thank you.